All right, well, this is just a quick video to go over some review topics for the second to last quiz of the year, quiz number 4. So this test is on arrays, sorting, and random numbers. So 3 kind of tricky topics. So first off, you should expect a question. Maybe I should back up for a second and tell you what the test is going to look like. There is, I think, 6 or 7 multiple choice questions. And work through multiple choice questions carefully because those can sometimes be misleading, and that's where a lot of people lose points. And then there'll be short answer code writing. I'm either going to tell you to do selection sort code or insertion sort code. So by this point, you should have all finished the sorting program. So one of those two is going to be on there. It's either going to say write selection sort, and you literally just have to write all the code for selection sort, including the helper methods, so find lowest and swap. Or it'll say write the code for insertion sort, which will be write public void insertion sort with their helper methods, find position and shift. So that's some guaranteed points you can get on the test if you memorize that code. And then there'll be 2 additional short answer questions. And those ones are kind of related to that second arrays homework that you should have just finished, where you had to find like the double letters and move stuff left, things like that. Okay, so good things to study would be your array note packet, your arrays homework, and looking at that sorting code. Okay, so first off, expect at least a multiple choice question on random numbers. It says identify the range of numbers that would be generated by the following lines of code. So math.random times 50. So remember, what's math.random? When you just see that with nothing else, what does that give you? That gives you a double between 0, including 0, but not including 1. So if I do this times 50 on it, we're going to multiply the bottom number and the top number by 50. So my ending range is going to be 0 less than or equal to x less than 50. Because 0 times 50 is 0, 1 times 50 is 50. Again, when you make this into an int, it lops off the decimals. So the ending range here, the lowest decimal I could get is 0. Or sorry, the lowest number I could get is 0 because 0 is included. And the highest integer I could get wouldn't be 50, it'd be 49. So this first example would give you code between 0 and 49. If you'd like, pause the video for a second and see what you get from this code. Okay, if you're ready to see the answer, again, math.random times 50. Math.random first gives you 0 less than or equal to x less than 50. Sorry, less than 1, technically, if you really want to show everything. And then I multiply it by 50. So now my range is 0 less than or equal to x, and then strictly less than 50. And then finally, it's going to add 1 to it. That's the last step. So now I've got 1 less than or equal to x less than 51. So when I make this into an integer by casting over there, the lowest integer I can get now is 1, and the highest I can get is 50. Okay? So know how those random numbers work. We've done questions like this. You might have seen them on some Google quizzes, but determine what the contents of the given array will be after 2 passes of selection sort. So you first need to know basically how does selection sort work. Well, there's 2 methods. There's find lowest, where it finds the lowest number left in the array, and then it swaps. So when it says after 2 passes, here's the original array. Now the first time it's going to look for the lowest number, so it's looking for what goes here. It finds 1, and it swaps them. So now 1 is here, 4 is here, everything else remains the same. So that's after 1 pass through. Now in the second pass through, it's looking for what goes in the second spot. So that's going to stay 1. It's going to look from here to the end and look for the lowest number left. and that's going to be 2. It's going to swap 2 with 7. Everything else stays the same. So after 2 passes through, this example is almost already sorted. The actual selection sort would keep going, but after 2 passes through, this is what the array would look like. Now here's a similar one with insertion sort. Determine what the contents of the given array will be after 3 passes of insertion sort. And when you see insertion sort, you should think of find position and shift. You want to know where the current element needs to be placed and then shift everything down to make that happen. So the way insertion sort starts is it assumes 4 is already sorted and it's looking for where 7 goes. So after the first pass through says if the first pass sorts the first 2 elements, you're basically looking where 4 and 7 go in relation to each other. So I'm looking at 7. I'm saying, is 4 less than 7? Yup. So 7 goes right here. So technically it takes out 7, shifts nothing down, and puts 7 back in. So after the first pass through, this looks exactly the same. But now these are sorted. Second pass through, it's looking for where 3 goes. And it says, is 7 smaller? No. Is 4 smaller? No. So 3 must go at the start of the array. So it saves 3 out over here somewhere, and it shifts. 7 shifts down to where 3 was. 4 shifts into where 7 was. It inserts 3 at the start of the array. 1, 2, 5 were never touched. And now the first 3 elements are sorted. I wanted 3 passes. So now the last one through that I care about. Where does 1 go? Is 7 less? No. Is 4 less? No. Is 3 less? No. So 1 goes at the start. So we save 1 as a temp variable, shift 7 down, shift 4 down, shift 3 down, insert 1 at the beginning. 2 and 5 were never touched, but that's what this question was asking. What's the array look like after 3 passes through? Okay, so those are some more multiple choice questions. Now there's not going to be a ton on Big O. I know their notes were probably a little tricky on Big O notation, but basically what you should know is what is the Big O efficiency for selection sort? That was O n squared. And that was for all cases. That's important. So whether it was sorted already, whether it was randomly sorted, or whether it was completely reverse sorted, it was always O n squared. Insertion sort was almost the same. It was O n squared for most cases in the average or worst case scenario. But in the best case scenario, what was its Big O notation? It was O of n, which means it takes considerably less time than selection sort to insert it, or to use insertion sort, if you're in the best case scenario. That's also important to know what that is. What do I mean when I say best case scenario? What's best case scenario when you're sorting an array? Best case scenario is that it's already sorted. Okay, so by the same token, what's worst case scenario? Well, that's if it was sorted in reverse order. So if I'm trying to sort from low to high and it's sorted from high to low, that's worst case scenario. That's going to take the most time. The average case scenario is what you'd run across most frequently. That's when it's just randomly sorted. Okay, so for Big O, all I would really be concerned about for the test is which is more efficient, insertion sort slightly, but only in the best case scenario, and know what I mean by best case, worst case, average case scenario. Okay. The only other thing I'm going to go over is practice writing this code for selection sort and insertion sort. So we're going to I would look at your sort.java class from that sort program, but let's say I want to do selection sort. And I would, again, at least memorize what selection sort means. It's find lowest and swap. So if I'm going to write out selection sort, here it is, public void selection sort. And you have to give it an integer array. Okay, we had one temp variable kind of, we called it a min. So it's going to look for the smallest value, the lowest. And then we have a for loop. The for loop starts at int I equals 0. I is less than a dot length. I plus plus, because I got to go through and sort every element in the array. We set min equal to a helper method called find lowest. And in order to use find lowest, you have to send it the array. So I'm sending it A. And I also have to know where I'm at in the array right now. So I have to send it I. After that, you're going to swap. And you're going to swap the element that you're currently at with whatever this minimum position is. So you got to send it the array, send it the minimum value, and send it the thing you want to swap with, I. That's selection sort. Now again, within that, we had to write find lowest and swap. So find lowest is a public int. If I do public int find lowest, ran out of room there, I have to send it the array, so int bracket bracket A, and I also have to send it the position I'm currently at, so I'm going to call it int position. Okay, and you've done find lowest a few times now. Let's say I'm going to say int min, let's say the minimum value is where I'm currently at, int min equals position. I want a for loop to go through the array, but I want to start at I equal position. I want to start where I'm currently at. I want to go to the end of the array, so I is less than a dot length, I plus plus, and I'm looking for something smaller. So if the current spot I'm at, if a bracket I is smaller than what I'm saying the minimum position is, a bracket min, then we found a new min. So min has to equal I. And then finally at the end, we're going to return whatever the min is. That's find lowest. Now the swap method, you also have seen a bunch of times now. So I'm going to do the swap method, public void swap. I have to send it the array. And I have to send it two things to swap with. It doesn't really matter that this is the minimum position and this is the current position. I'm just going to call it int x, int y. Two things to swap. And to swap two things, you don't need a for loop. You just make a temp variable. So int temp equals a bracket x, one of the two values. We set the thing I just saved, a bracket x, equal to the other value, a bracket y. And then at the end, I have to set a bracket y equal to that original thing I saved. And that's swap. Okay, so that is selection sort, those three methods. And that might be on the tests. And if I say write selection sort and its helper methods, that's exactly what you have to write. If you're good at memorizing, you can memorize it, but I would really suggest knowing how to do it. That's really the better way. All right, so let's write insertion sort quick. Now people find insertion sort a little bit harder, and it is a little bit more complicated. Okay, so here's a given array. The nice thing is the insertion sort method is pretty similar to the selection sort method, except instead of find lowest and swap, we have find position and shift. But pretty much everything else stays the same. So instead of int min, I'm going to make an int called position. I'm going to make a for loop going through the array. I equals 0, I is less than a dot length, I plus plus. And inside the for loop for each spot, you want to do the two helper methods. We want position to equal find position. And I want to send it A and the spot I'm currently at. Then instead of swapping, we want to shift. Again, it needs the array A, it needs the position I'm shifting to, and the current position I'm at. Okay, so that's the overall insertion sort method. Now some people always ask, could you put a 1 here? And yeah, you could. That's either 0 or 1. If it's 0, you don't really like, insertion sort doesn't really look for where the first number goes, it's just going to stay where it is. So it's not going to mess it up at all if you put 0 here. You can put 1, that's really how insertion sort works, but 0 works just as well. Okay, let's find position. So public int find position. And we need to give it the array, so int bracket bracket A, and you need to know the spot you're currently at. So I'm going to call it int cur. Now think about how I found the position. I'm starting when where I'm currently at. If this is my array, if I'm looking for where, let's say I'm here and I'm looking for where 2 goes, I take where I'm currently at, I start at that spot, and I work backwards. So my for loop starts at the current position I'm at. I'm going to go backwards as long as I is greater than or equal to 0, the start of the array. Since I'm going backwards, it's I minus minus. Each time I'm checking, is this spot less? So if A bracket I is less than A bracket cur, the current position I'm looking at, that means I've found where it goes. So I would say, are you less? No. Are you less? No. Are you less? Yes. So position 0 is less. But 2 doesn't go in position 0, it goes 1 to the right of it. So once I find something less than it, we turn I plus 1, position to the right of it. If you get all the way through your for loop but never find anything left, where does it go? At the beginning, so you return 0. That's find position. Okay, then finally shift is a public void. And public void shift starts with the current array, and you have 2 positions. Let me make sure I'm matching it up. Position is where I'm moving to. I is where I'm currently at. So this is essentially where I'm ending up. This is where I'm starting. So I'm going to say int end, int start. And if I take this same example up here, 1792, we know 2 has to go right here. So my first thing that I do is I have to save 2 over here somewhere. So int temp equals a bracket, the current position, the start. Now I want to go from that position down to where I'm going and shift everything over as I go. So I'm going to go backwards through a for loop again. For int I equals start, I want to go I greater than where I'm ending, because I don't want to shift the 1 into where I'm ending. I want to stop once I get to this spot, so strictly greater than end. I minus minus. We're going to shift we're going to set the current spot, a bracket I, equal to the spot to the left. So it shifts everything down. And then finally, once I'm down to this spot, now I can put my ending position, a bracket end, equal to that number I saved, which is temp. All right, so that's it. Hopefully that helped you review how those two algorithms work. Now try the other review for the quiz, the Google quiz, and after that you'll be ready to take the test. Let me know if you've got any questions. Good luck.